Hi, everybody. We're going to work through a calculation known as the fifth year projected water usage per day calculation. A lot of folks struggle with this calculation because it's kind of a tough one to figure out without a direct formula for it. And you'll probably find that there's no formula on the formula sheet that's really easy to help you with this. So I'm going to try to guide you through it. And hopefully this will help uncover the mystery of how to get that fifth year projected flow rate. So hopefully on the slide you see where it says where an operator may have to project what the water usage is for their growing community over the next few years. You may have to try to plan for maybe expansion of your water plant or drill new wells or look for a new water source, to supply your community if you're growing at a pretty fast rate. So I have a few examples here that I'm going to walk through with you guys. So the question on the screen shows calculate the fifth year projected water usage per day for a community water supply that is growing at 12% per year. The current population is 125,000 people and the average usage is 110 gallons per person per day. So on the screen that is in front of you, you should see where it says year zero is 125,000 people times 110, we're going to make a multiplication here, times 110 gallons per person per day. So that comes out to be a current flow rate of 13,750,000 gallons per day. So what we need to figure out is what are the subsequent years, what is the flow rate going to be for those next couple of years, finally ending at year number 5 is where we really want to be. And one of the things that I want to kind of caution you on is that we can't just multiply the growth of 12% times the number 5 for the 5 years and come up with a number and then multiply that in, because each of these years is based off of the previous year's flow. So this is kind of like accruing interest, if you will, like where you actually have money into your bank account based on what's previously there, getting interest in your bank account. Anyway, you know what I mean. All right, so I kind of wrote up a little summary here on how you could do this. There's a couple of ways you can calculate it. You could multiply the percent growth for the population of 12% and then just keep adding the 12% in for each year on the population, and then finally multiply that by the 110 gallons per person per day. Or you could figure out what the flow rate is each year based off of the previous year's flow rate, so of 12% increases. So you could do it several ways. So for example, we have where it says here 2 ways to calculate it. You can multiply the beginning yearly flow rate by the percent growth, as a decimal, which would be the 12%. As a decimal would be 0.12. So, or I'm sorry, in this example, 0.11, what we're showing here, an example of 1,547,000 gallons per day times 11% would be, this is the difference, and then adding that back in to the original flow comes up with the new gallons per day, right? So we had 1,547,000 gallons times the 11% difference is added back in. So you could do that. That's an extra step that we can take, and you can figure out what your flow rate's going to be. Or you can cut out one of the steps completely and just add the 11%, say for this example, right into the original number, which would be represented by the whole number 1 as 100%. So let me show you what I mean. If we have 1,547,000 gallons that we said, and we're going to increase that by 11% each year, then our multiplication factor becomes 1.11. The number 1 represents the whole number from the previous year, which is all of that flow. And then the 0.11 is the additional 11%, just multiplied directly in. So kind of saves you a step. And you can kind of see that we get the same answer. So method number 2 kind of solves or removes one step from the equation that you don't have to worry about. So I'm going to kind of give you an example here. I think we have 2 examples on the screen coming up. So we're going to calculate the fifth year projected water use per day for community water supply that's growing by 12% a year. The current population is 125,000 people, and the average usage is 110 gallons per person per day. So we have 125,000 people times 110 gallons per day per person, right? So what is our current flow? We need to know what our current flow is, so we can start from there. We have to start from year zero is our current flow. So 125,000 times, we said 110 gallons per person per day. So I'm coming up with year zero of 13,750,000 gallons per day of water production at my water plant. Now, we're going to increase this by 12%. We have 12% right here, 12% for each year up to the fifth year. So we need to know year number 1, year number 2, year number 3, year number 4, and finally ending at year number 5. These are all going to be years, right? So we're going to add that in here. Year 1, 2, 3, 4, 5. All right. So based off of the original flow that we have right now, which was 13,750,000, we're going to multiply that times the factor, the multiplication factor of 1.12. Remember, that's our multiplication factor because the 1, the number 1, represents what we have now, and the 12, the number 0.12, represents the growth. So on your calculator, you got 13,750,000. Multiply that times 1.12. So for the year number 1 growth, I have 15,400,000 gallons per day from my water plant. Now, based off of that flow, I need to then multiply by 1.12. So times 1.12. And for year 2, I'm going to be pumping 17,248,000 gallons per day. Okay, keep right on going. Year number 3, so times 1.12. Year number 3 is going to be 19,317,760 gallons per day from my water plant. Now, for year number 4, multiply times 1.12, and we've got a flow rate of 21,635,891 gallons per day. Let me kind of make sure that this is good separations here between these numbers so we're not confused. And the last one for year number 5 is our number is then multiplied times 1.12 from year 4, and we end up with a final number of 24,232,198. This is going to be gallons per day of flow rate from the water plant. All right, so that's our final answer. Okay, so hopefully that helps with that one. We're going to try one more example here. Remember that you have to start with year 0 and then keep accruing this percentage interest over time. So let's look at one more example. How about this one? Calculate the fifth year projected water use per day for a community that's growing 15% per year, and the current population is 200,000 people, and their usage is 150 gallons per day per person. So we have year, we know we got to do a bunch of years here, so I'm going to put year 1, 2, 3, 4, and 5. We're going to go like this. And we're going to fill in each one. And we know that the current population is 200,000. So we have 200,000 people times 150 gallons per day per person. So 200,000 times 150 gallons per person per day. I'm coming up with 30 million gallons per day from my water plant. So that's what I'm meeting for the demand right now, 30 million gallons a day, 200,000 people, 150 gallons per person per day. Sounds like they need to conserve some water and maybe cut back a little bit on their usage, but that's a lot of water. But anyway, let's keep right on going. So we got 30 million gallons a day. And now my growth factor is 15%. So instead of just trying to figure out the 15% and keep adding it back in, we're just going to multiply each year by 1.15 because that's my new multiplication factor. So 30 million times 1.15 is 34,500,000. So 34,500,000 for year number one times 1.15, and I get 39,675,000 gallons per day times 1.15 is 45,626,250 gallons per day times 1.15, and I get 52,170,188. I'm going to do a little rounding there. 52,470,188 gallons. And then finally for year number 5 times 1.15, and I'm going to be pumping 60,340,716 gallons per day on the 5th year of my water plant operation, based off of a growth of 15% per year. So you can kind of see from this calculation that our water usage will more than double in 5 years than what we're at right now. So a little bit more than double. We're at 30 million right now, and by 5 years, we're going to be a little bit over 60 million. I think it's probably time to either conserve some water or build a new plant or find a new water source, or a little bit of all of the above, and make sure that you can meet the demand of your population. So that's how you work that out. I hope that video was helpful. Let me know. Again, my information is rtrigar. I can write it up here at trio.ufl.edu. Sorry, it's a little scribbly here. Trio, or 352-294-3881. And I hope that helps. Thanks, everybody. Can't get it to turn off. We gotta end the meeting. End meeting now. Bye.